Okay, let's talk about the Pauli exclusion principle. The definition of it, of what we have, is that no two electrons can have the same quantum number. So we're going to try to simplify that a little bit. Quantum numbers is kind of a difficult concept. We see that it represented as our N value, which is our energy level, our I, which is our angular quantum number, we have our magnetic quantum number, and then we have our spin. And in quantum numbers, we're really not going to use it a lot in pre-AP, but basically what this means is that no two electrons can have the same spin. Basically, they can't. The arrows that we have in writing our arrow notation, they can't be going in the same direction. They can't be flowing from each other, having the same spin as each other, going in the same direction. They have to have opposite spins. So an example of this, and looking at this, says draw the electron arrow structure for fluorine and justify your answer using the idea that spinning electrons form tiny magnets. So basically what's going to happen is as it spins, it kind of forms a north and a south pole, and it kind of creates this. And basically what we have our fluorine one, which we've already done our example of. There is the one we did for nitrogen. So we look at our periodic table and we know that our fluorine, okay, so we'll go to our periodic table and we write for fluorine is just two more electrons. So instead of being 2p3, it's 2p1, 2, 3, 4, 5. So it's 2p5. That's our electron configuration. That's the only thing that changed because all we have is just a couple more electrons. So we'll take this and use this as our example in dealing with fluorine. So we're looking at this and it says draw the electron structure for it. So here's our electron configuration, which we'll keep that. And it still draws out. The 1s still has 1. The 2s still has 1 because they're s orbitals. And then we have 2p, which has 1, 2, and 3. So to follow our Hund's rule is we say that it goes 1. You must get 1 before you get 2. So 1, 2, and then 1, 2. And then we go 1, up, up, up. That was 3. So since they each have 1, to follow the Hund's rule, now we can have 2. So they each have 1, so then they have 2. So we have 1, 2, 3, 4, and our last one is 5. And so basically we draw it so that one arrow is going up, the other arrow is going down, and it represents the Pauli exclusion principle that they have to have different spins, opposite spins, because they're going to have tiny little magnets. They're pushing each other around, keeping the electrons because they have the same charge.